Bismillah ar-Rahman ar-Rahim. We started talking about firewalls. We mentioned the responsibilities of the firewalls, having to provide second level of protection after providing all the security mechanisms for the host in different layers. We talked about the different types of firewalls. We talked about packet filtering, which is the primitive one, which has a list of policies or rules, and based on that, it applies it to each individual packet or traffic, and then it applies these rules. If the rules passes, then it either pass through the traffic or discards that traffic. We also covered the stateful, in which case this not only applies the rules but also keeps track of the states of each TCP connection end to end, and if the incoming packet, even if it fulfills the rules but it does not belong to any of the connections, that also will be a reason for discarding the traffic. Today we're going to talk about these two types, and then we will discuss the different categorization of firewalls with respect to implementation and with respect to deployment. So it comes to the third type, which is application level gateway. Application level gateway is also called application proxy, and it acts as a relay of application. So as we said last time, that the other two types, they focus on, if you have like a big protocol data unit, we have the data link layer header, we have the IP header, and we have the TCP header. So the other two types of firewalls, they focus on these headers in terms of applying the rules. So they apply the rule based on what IP, what port number, and what is the physical address, and so on. So they can apply rules based on this simply. So we have, of course, the application header, right? Which the application header, this is actually, in terms of OSI model, this is part of the session layer, right? And this is actually the application layer, okay? So when it comes to application level gateway, the application level gateway actually, it monitors these two. So it can look at the application level data and the header. And what happens is that so this is the firewall, and when the traffic comes in, it actually passes through the firewall, and then the firewall has, this is like this is the input TCP connection, okay? So this application level firewall will actually forward this TCP connection to an external TCP connection, okay? So as we all know, the proxy is that when you connect to the proxy, first you have to, some proxies, they require the fact that you have to authenticate, okay? And this is also different from the other two types, because the other two types, they don't require authentication, which means that you can facilitate something like IP spoofing. So I can do IP spoofing. I can spoof my IP address, right? And pretend that I have an internal IP address and then pass through the rule-based firewall, right? Or the packet filtering firewall. For the application level gateway, some proxies, they actually require authentication. By authentication, I make sure that there is no IP spoofing, and I make sure that the person who's connecting is really the person who says who is. So in that case, I guarantee that it's coming from an authentic source. And then what I do is that I have to make another external TCP connection to the destination, right? And of course, during this process, during this relay process, I can do some, again, restrictions based on the application level data. So I can say, okay, so this is HTTP or web service, and this is like, for example, this is a request, HTTP request, مثلا to buy something from Amazon. I'm going to restrict that, okay? So it looks at the application level header and the data itself. So not only can I restrict certain applications, I can even restrict some application level functions because I look at the actual data itself, okay? So I can do whatever restrictions I want in the application. The application type, the application function, I can restrict some functions and bypass some functions, I can do that. So, of course, I have to pay an enormous cost for this because monitoring the application level data requires a huge amount of overhead, as you can imagine, compared to the fact that I'm looking at certain headers and then I'm trying to apply certain rules. It's not as simple as that. Then I have to look at the application level data and really filter based on the application level data, which is a big overhead. So this is the idea of being able to relay. So when we relay, this means that the incoming TCP connection will be transformed into another external TCP connection to the ultimate destination. So for the ultimate destination, it looks as if the connection is coming from the proxy, not from the actual source, okay? And during this process, I can do whatever types of filtering or restrictions based on the application level data. واضح كده? So if the gateway does not implement the proxy code for a specific application, the service is not supported. So I can do some restrictions. So the application level proxy can say, okay, so this incoming application level traffic is actually restricted or discarded. So the gateway can be configured to support only specific features of the application. So it's not only on the type of application only, I can restrict even some functions inside the application because I look at the actual data of the incoming traffic. It tends to be more secure than packet filtering, obviously, because it doesn't really look at the policies and the rules only, but it actually looks at the application level. So some traffic that it comes from, like for example, a legitimate IP address and so on and so forth, and this IP address is spoofed, right? And if the IP address is spoofed and you don't do authentication, it passes through the firewall, and then it ends up being a network injection attack or something like this, and it adds some routing information to the network in a wrong way, and it corrupts the whole network. Of course, the disadvantage, as I said, is that there is some additional processing required because of the fact that you have to look at the application level data, which takes a very, very long time. So these types of application, usually it's done as part of a dedicated host, which is usually very, very high-end and very fast. Okay. Type. Again, on the same level is what we call the circuit level proxy. So this is slightly different from the application level proxy. This does not look at the application level packet by packet. It looks at the entire application level traffic, but it has to, it filters based on the fact that this is a specific HTTP traffic that is coming in, and it belongs to the same session. It belongs to the same HTTP session, okay? So in that case, I can apply the circuit level restrictions on the level of the session itself. In other words, so if you look at the application, you have the header, which as I said, it belongs to the session actually. So you have HTTP. So HTTP header, it gives you some information about the session, right? The session which is actually constructed or established between one web client and one web server. So this session is like you are doing like some workflow to buy some items from Amazon, so you keep communicating back and forth to the server of Amazon and so on. That's a session, okay? So the circuit level proxy, it looks at this session level header and it applies the restrictions based on that. And also, but it doesn't look at the application data. That's what I'm trying to say. So it doesn't look on a packet by packet basis or data by data. It looks at the entire circuit. And the circuit here is a complete session between a client and a server. And as part of this, it does not permit the end-to-end TCP connection. So similar to the application level gateway, so you have an incoming TCP connection and you have an outgoing TCP connection. So it breaks the end-to-end into two different TCP connections. So one incoming and one external, right? The security function consists of determining which connection will be allowed. So all it does is that it says, okay, so I have here an output connection, and then it actually forwards from this to this, or from this to this, and so on. So it forwards some input connections to some external connections, but on a circuit by circuit, not on a packet by packet level. This is the difference. And that's why this is sometimes the circuit level gateway is actually implemented as a complementary function in the application level gateway, as only a complementary function, okay? So typical use for this situation in which the system administrator trusts the input users and can be configured to support application level or proxy. This is what I'm trying to say. So the circuit level can be implemented as part of the application level gateway as well. One of the most famous one, which we used to use in the past, of course, not anymore because of the fact that now people usually use VPN, which really is a lot more secure than this. The SOX server, sometimes some software, they have a configuration where you have to put SOX server. The SOX server is actually the proxy server. The proxy server can be application level and or circuit level proxy. واضح? So it can provide application level proxy and or circuit level proxy. Okay, so apply one of them or both. So now, so these are the conceptual types. We have 4 types conceptually. We have the packet filtering, stateful inspection, we have the application level proxy, and we have the circuit level proxy. So these are the 4 conceptual types. So when it comes to implementation, how can we implement these 4 types individually or combined, okay? And how can we implement this in a deployable component? Can we deploy it مثلا in a standalone host? We deploy it in access point, we deploy it in routers, we deploy it in anywhere, okay, in the network, okay? So based on host, this is a system which is identified by the firewall administrator as a very critical, strong point in the network security. And this is usually a standalone host, okay, which is marked as a very critical security point in the network. Why? Because this host is where they implement the firewall functions, okay? So the common characteristics of these types of hosts is that it executes a secure version of the operating system. So I try in this host, because this acts as a firewall, okay, usually it's a very high-end host, especially if it performs some application level gateway functions or proxy, okay? It requires to be very high-end, very, very fast, and extremely secure, okay? Extremely secure, this means that I need to provide, or I need to set up the least amount of software on this host and dedicate this host only for the firewall functions, okay? So the operating system itself is very limited in terms of functionality, ماشي? And of course, it has very high or hardened policies when it comes to access control and so on. So only the service that the administrator considers essential are installed. So I don't use this for general purpose software. It's the host that's used for firewall. I might as well use it for office. No. These types of hosts or parts of the system, they need to be very, very secure. They need to have the least amount of software so that they would be dedicated for firewall functions. And may require additional authentication, of course. So the authentication is very much hardened. Each proxy is configured to support only a subset of So I can have multiple proxies on this host. And each proxy acts as a proxy for a specific one or more applications. Okay? So I can run one or more of these proxies independently. Why do I do this? Why do I run multiple proxies? Because having these proxies independent as individual components allows me to make restrictions customized for each application. And also, if there is a problem in one proxy, like there is a security compromise on one proxy, does not affect others. So what I'm trying to say is that the security level here has to be the maximum security level, okay? So each proxy is configured to support only a subset of standard applications command set. Each proxy is configured to allow access only to specific host systems. So I can provide restrictions that this proxy is accessible only by subset of system components. So I cannot allow incoming traffic from any source system. I can restrict only certain types of systems, and I can also put some restrictions on the output or the destination. So I can put restrictions on both, okay? So because I do authentication, so the input system, they have to authenticate themselves to the proxy, in which case I can really discard or disallow some of the systems. And also, even if you authenticate and you send a request to the proxy saying that I want to connect to this website, I can do some restrictions and say no, I cannot make the call to this website. Each proxy maintains detailed audit information. This is one, as I said before, this is one of the very common functions of all the firewalls, is to be able to audit security activities, right? Each proxy module is very small software package, okay, specifically designed for network security. So as we said, so we try to make, and actually, يعني, if you talk about مثلا إيه, if you talk about mail server is, it could be really a scalable and very complicated server, right? But mail proxy is a very lightweight software, صح? Because the main function of this mail proxy is not to do mail activities. It's actually to forward the traffic related to the mail application, اللي هو SMTP. مفهوم النقطة دي؟ So the mail proxy is very lightweight, بينما the mail server is very heavy, right? So here, each proxy itself is very, very lightweight, only to provide certain restrictions on how to forward the traffic related to a certain service or application, okay? And each proxy is independent of all the other proxies. As I said, so it runs, يعني, you have this Bayesian host, so this Bayesian host, so this is the Bayesian host, and it runs group of proxies. Each one runs as a process, okay? So this is مثلا the mail proxy. This is مثلا telnet proxy, and so on. Amen? So why do I do it independent and they run separately like this? Of course, each one of them is lightweight. Its function is not to provide the actual service of mail or the actual service of telnet. It's actually to provide restrictions on the traffic that uses that particular application, right? And why do I make them independent? Because if one of them is compromised, it does not affect others. واضح كده؟ طيب, so a proxy generally performs no disk access. As I said, it only relays the traffic, but it does not perform the actual functionality of telnet or mail or something like this. So it does not really provide or perform disk activities. It does not access the local service, the local system, except to just read some configuration. Read some configuration file at the beginning, and that's it. Other than this, what I'm required to do is to relay traffic. Okay? So I don't have to مثلا read email and store it in the system, or get some email component from the system and send it for. I don't have to do this. So activities related to the local storage of the system is very, very, very limited when it comes to proxies. So these are all characteristics of these types of host-based firewalls, ماشي? Or what we call Bayesian host, ماشي? Each proxy runs an unprivileged user. So usually, as I said, the access privilege for to access these proxies is usually very, very limited, except for the administrator, of course. Type. So host-based firewalls is very, very common. So it's a host-based firewall. It runs as a software module which is used to control individual hosts. Host-based firewalls are very, very common. So all of us, we have firewalls on the laptop. This is called host-based firewall. This is different from enterprise-level firewall, right? So host-based firewall is, and usually this is merely for packet filtering. Usually, we do packet filtering. Some host-based firewalls, they can also be used for application-level gateway. is available in many operating systems. They are built in the operating system. زمان we used to use separate firewall software, but now it's built in the operating system. It filters and restricts flows or packets, and common location is usually طبعا servers would have these host-based firewalls by default. ماشي؟ يعني انت for your laptop you may choose to disable the firewall. You can do that, but for servers it has to be there. Filtering rules can be tailored in terms of advantages. The filtering rules can be tailored to the host itself, to the host functionality. So I can مثلا provide some rules to do certain restrictions for any application in my host, مثلا office ولا حاجة زي كده. Okay, I cannot do this for enterprise level firewalls. Okay, here in the host-based firewalls, I can really customize the rules based on the software inside that host. Protection is provided independent of the topology. We'll talk about the topology هنا بقى. The topology here, again, firewalls can be again implemented and deployed in a distributed way, as we will see in a minute. Okay, so the host-based firewalls, it can be part of the entire administration of the distributed firewall, or it can be independent. يعني بمعنى إني I have a big network. Each network has a host, has multiple hosts, and we have enterprise level firewall, okay, which it provides some protection against the incoming traffic, right? So inside here I could have host-based firewalls on each host, okay? And of course we have the big dedicated firewall for the entire enterprise, right? I can have all these under the same administration. يعني مثلا the ITS, they can in fact populate rules to your host-based firewall. Okay, we can do that, or we can make these host-based firewalls independent of the topology, so they are not controlled by the administration of the firewall in this enterprise. They are independent, so you have access to configure all the rules inside your host-based firewall independently from whatever other firewalls exist in the organization. ماشي؟ طبعا this is used in conjunction with standalone firewalls, as we said. يعني these host-based firewalls are supposed to be complementary to the enterprise level firewalls. ماشي؟ يعني you can consider them as a third line of defense, if you will. If we consider this the second line of defense after the host-based security mechanisms, then host-based firewalls they provide the third level protection. Type personal firewalls. So unlike host-based firewalls, which is like software that runs on the host, you can have personal firewalls are supposed to be slightly separate from the host. Okay, you can use these personal firewalls to provide security restrictions between the personal computers and an external network. So it could be in the middle, not running on the actual host itself. So, exactly, Allah knows, exactly, that's exactly right. So you have one or more hosts, right? And you have a firewall here, you have a firewall software, okay? This firewall software module, it can run on a dedicated host, or it can run on a router, or built in the access point, okay? And it provides the protection between this internal network and the internet, okay? Type. It can be used in a home environment. This is very, very common for home environments, okay? And this is برضو على فكرة, this is different from enterprise level firewalls. Enterprise level firewalls, these can be dedicated hardware, or at least dedicated machine to do the firewall functions to protect the entire enterprise network. That's another level. Typically is a software module برضو that runs on a personal computer or the router. ماشي? It can also be housed in a router that connects all of the home computers to DSL or to modems or to other. يعني هنا مثلا could be مثلا هنا DSL line ولا حاجة to the external network. ماشي. Can also monitor outgoing activity in an attempt to detect and block worms. So this is an example of firewall configuration. This is what we call topology. This يعني firewall بقى topology. So in addition to the network topology, we have بقى a topology for the firewall. So here we have, if you notice here, we have external firewall. External firewall usually is connected with the boundary router اللي احنا we used to call it a default gateway. فاكرين network 1 we used to call it default gateway, which connects our network to the outside world. Okay, so after this default gateway we have the external firewall, and this external firewall it provides يعني ايه some level of protection, but it doesn't necessarily have to provide the highest level of protection. And why is this? Because here, after this external firewall, we have what we call this stands for demilitarized zone. Demilitarized zone, or DMZ, this is supposed to be, it's an internal network of hosts that are very commonly accessible from outside. Okay? Like, for example, you have mail server, you have telnet server, you have all of this. So if we provide here, if we do the highest level of protections, this means that these servers might not be accessible from the outside, which defeats the purpose, okay? But of course, you have other parts of the network which are internal protected network. These are not demilitarized zone. These are militarized zone. This is a militarized zone. It should be highly protected. These are internal assets which should not be accessible from outside. ماشي? So in that case, we put two levels of firewalls. We put external firewall and we put internal firewall. This internal firewall provides even higher level of protection, okay, to protect the internal protected network. In between the external and the internal, we have what we call DMZ, which usually contains part of the network which should be commonly accessible from the outside world. واضح كده؟ ماشي؟ Any questions? So this is one topology or يعني deployment configuration that we can have in the network. If we add the host-based firewalls to this means that we have some host-based firewall on every single host. صح? We could have host-based firewalls on every single host. So we can do that deployment slightly differently, which is what we'll talk about in the next slide. Here we talk about VPN, because we said that firewalls, they could very well support IPsec. صح? So in that case, firewalls can help us to provide or to perform network-to-network communication, okay, secure private network-to-network communication over public internet, which is unprotected. Okay, so this is VPN, and we talked about this in chapter 9. Of course, we killed it in terms of details and discussions and stuff like that. So you have here firewall that implements IPsec, and you have firewalls implement IPsec, and in between these two networks, we can have VPN. So here you have to add the IPsec header, which we talked about in chapter 9. Okay, so nothing is new here. So this is the configuration I was talking about. This is another deployment configuration which provides host-based firewalls. So if I have host-based firewalls, which means that I have software process that runs on every single host, okay, then I can take that into account by saying, so I can actually use some external DMZ or demilitarized zone, okay? So I can have, in the boundary router, I can connect some web server, and this web server usually مثلا is is very highly accessible. This is the main web server of the company that represents the company, right? So I can connect this to the boundary router directly without the firewall, right? And rely on the host-based firewall to provide the necessary protection for this web server which mean بقى ان احنا ايه in host-based firewall we can configure customized rules for this particular host, and for this particular host the customized rules will be necessarily and specifically for web service. Okay, so in that case I don't have to include this DMZ or external DMZ after the external firewall. Why? Because I'm relying here on the host-based firewall, which runs on the actual host. ماشي? So this is external web server, and then the DMZ will have some other types of service which also will be accessible by the outside world. But here I can have the host-based firewalls on each of these servers. طيب, what is the difference between this and the other one? Remember, just the fact that I have this external DMZ and internal DMZ in addition to the internal protected network. So here I have 3 levels of the network. I have external DMZ, internal DMZ, okay, and then the internal protected networks. And DMZ, again, DMZ refers to the fact that these hosts should be accessible from outside world, okay? So all of these host-based firewalls, together with the external firewall and the internal firewall, could actually be part of one administration system. Okay? So just the fact that I have individual firewalls like this, some of them are host-based firewalls, some of them are personal firewalls like this, okay? It doesn't mean that they are totally separate and totally independent. I can have one single management or administration system to control all these firewalls, and there is management software for this. In ITS they do this, okay? They can apply the rules on your host-based firewall in your laptop, okay, if needed. واضح كده? So this is another configuration which has 2 levels of DMZ regions or DMZ sub-networks. So you have external DMZ and internal DMZ, and in that case, typically you have host-based firewalls to complement or to provide some level of protection in the external DMZ. Okay? That some firewalls, by the way, they can be implemented as part of an enterprise routers, in which case, interestingly speaking, this firewall could in fact be implemented inside the router, in which case the firewall itself will have multiple interfaces. The firewall itself will have multiple interfaces. Okay? Here, we show the configuration where the firewall is separate. It could be hardware, it could be host, right? And it's connected with the router. But in fact, we have here, the firewall itself has multiple interfaces. ماشي? You have basically one firewall, and then you have the entire network. So there's no bad DMZ, and there's no like extra levels of. Here, I can have third network interface, and this could be connected with the external DMZ, and I rely on the host-based firewall as part of the DMZ to provide some level of. This configuration is called double Bayesian inline, where you have DMZ. They call it sandwiched between external firewall and internal firewall. So the DMZ lies in between, and you have 2 firewalls on either side to provide. So this firewall, it could be integrated with the router, and it could have multiple interfaces. By T, we always mean that the firewall itself has extra interfaces. Okay, it's like it has a router functionality in addition to the type. So based on that, you have these are multiple topologies. These are different types or different common topologies that are usually used. I have one of the topologies called the single Bayesian T. By T here, I mean T connection, which means that the fire. So you have host resident firewall, and this category includes personal اللي هي personal firewalls as we said, whether it's a software process that runs on a separate host or on a router. This is called the host resident firewall, and this is one common topology, and it can be used as standalone or as part of a in-depth firewall deployment. So this is the host resident firewall. We have screening routers. Screening routers are routers that implement the firewall functionality. Okay? So it's a single router between internal and external networks with stateless or full packet filtering. Usually these types of firewalls, it's implemented either in access points or routers. Okay? Single Bayesian inline, and this is a single firewall device between an internal and external routers, which is what we showed here. And this is typical firewall appliance configuration for small to medium networks. So for small enterprises, or medium enterprises, we usually use configuration like what we have here. There is a single Bayesian T, which means that in similar to a single Bayesian inline, but has a third network interface. Okay, so here I can have. So there's double Bayesian inline. Double Bayesian inline. This is the protection. This is what we call it double Bayesian inline. You have DMZ sandwiched between two baseline. And there's double Bayesian T, which means that functional. So this is what we call double Bayesian T. And in general, طبعا distributed firewall configuration used by large businesses بقى, similar to مثلا QU ولا حاجة. You have the distributed firewalls, and as I said, it contains multiple of these topologies. It contains a combination of all these topologies. You have host resident firewalls, you have routers with firewalls, you have single hosts with firewall functionality, you have Bayesian T, you have a combination of all of this. The key here is that for distributed firewall configuration, all of these firewalls could be administered through one system of administration. You can configure all the distributed firewalls through the same system or the same administration. ماشي كده؟ Any questions? So this is the summary for the firewall. So we talked about the basic functionality of the firewalls, of course. Basic functionality to provide protection. This is the second line of defense after the implementing all the host-based security mechanism in different layers, which we covered, of course, in the previous chapters, starting from the network access security to the IPsec, TLS, and all of these levels of security. As we said, these are not enough, so we have to provide second line, and firewall is a second line of defense. And in addition to the fact that firewalls are used to provide security-related audit logs, which is very, very important. And of course, we have covered the types of firewalls, the conceptual types of the firewalls, packet filtering, stateful inspection firewalls. So packet filtering, they provide rules on packet-by-packet basis, and these rules are simply related to IPs, ports, MAC address, things like that, okay? And it applies it to a packet-by-packet basis versus the stateful inspection. So in addition to these rules, we also keep track of all the states of all the TCP connections, so that if I have an incoming packet that does not belong to these connections, even if they fulfill the rules, I can also discard that type of packet. And we also talked about the application level gateway or application level proxy, which is used to relay the application level data, and it looks at the application data itself, and it can provide some restrictions even on the features of the application. Circuit level gateway provides, again, restrictions on the session level. So it only looks at the application header, and it can provide some restrictions on a session, but not on on the actual data of the application. It doesn't look at the application data at all. Then we talked about the firewall basing, the different types with respect to the implementation and the deployment of these firewalls. And we talked about the locations and the different deployment topologies, including the DMZ networks, the private networks in terms of VPN, distributed firewalls, and the topologies. طيب اتفضل.
Can I press
Yes, it can. Yes, yes, yes. Many of them, they can do this. But again, because if you do the application level gateway on a level of a small office of an enterprise, it's fine. But imagine that if you use this مثلا to provide application level proxy for a big organization or for a region, in that case you need because as we said, the application level proxies they have to have additional processing capability because they look at the application data. They can filter even, they say, okay, so you are trying to do HTTP requests to buy items from Amazon, I'm going to restrict this. In order for the application level proxy to say this, it has to look at the data itself. It has to understand the data. And this, of course, requires huge amount of extra processing. So again, to do this on a level of a home network, you can do that. أنا عندي في البيت, I have 2 levels of firewall. There is a firewall which is implemented inside the router itself. Okay, it comes with the router, basic and this acts as packet filtering. So you can restrict access مثلا to certain hosts, to IPs, ports, things like that. So it acts as packet filtering. Okay, there is a software that you can buy on top of this that provides application level restrictions. Of course, I do this for parental control for my kids. And then you can filter. You can say YouTube will be restricted to specific time of the day. You can do that. Okay, but you have to pay. But again, this type of software, of course, if I do it for an enterprise like QU, it has to be done on a dedicated hardware or a big, huge host with very high-end capabilities. صح? But for your home network, it's fine. Imagine.
Well, for most configurations or like most organizations or homes or whatever, they do a combination or a hybrid.
Yes, exactly. Which is what we talked about. So you have your host-based firewall, but you also have a multiple dedicated firewall hardware and software modules that run on different hosts, right? But the key here is that usually for these types of enterprises, all these firewalls, they run within the same administration. The person in ITS, they can control the firewall rules on your laptop. Because you are, of course, if it's part of the domain. Okay? That's why they restrict people to be always inside the domain of QU, because then they have full control. They can really control many of the software on your machine remotely. Okay? طيب. خلاص كده? Any other questions?